In this video, we'll continue our discussion of line integrals by working on another example. So we have this line integral. What's different here is we have two segments. We have one line from 1, 2 to 3, 4, and another line from that point to 4, 0. How we're going to want to do this is define the lines separately and then put them together. So let's begin with that. C1, I have x of t equals, we just look from 1 to 3 is 2, and then we put plus 1 where it starts. Y of t, I look at it goes from 2 to 4, so it's a growth of 2. That's my rate, and it started at 2. This is for t 0 to 1. All right, and we're also going to want something else here that's actually going to help us out quite a bit. Notice that this looks a bit different with the dx and the dy in different spots. We actually can take our definitions here and find a dx, and we're just going to replace it with that. Dx is 2 dt. That's going to change, and dy is the same thing. It's going to change our integral from dx's and dy's to dt's. Now, that's just for one path. C2 is going to be a bit trickier. Okay, so C2, what I would really like, and we should probably call this x1, y1, x, it doesn't really matter, but okay, x2, though, of t, is 3 to 4, so it's a rate of 1, but it started at 3. Y2 of t started at 4 and went to 0. That's a rate of negative 4t, and it started at 4. Now, here's the tricky part here. That's not going to hold. It will hold for this, right? That'll hold, and I could do two different integrals, and actually I would end up at the same answer. But our solution manual doesn't do that. They want this path to be uniform. What they mean by, and uniform is probably not the right word. Continuous would be a better word. We want the path to be continuous, meaning that I want to start my next thing at 1, and then go up to, ideally 2 would be fine. So what we're going to do is take your t that you had, and let me scoot some things out so I can show you exactly what I'm going to do. Whatever the t is, I want you to erase it and put a parentheses. So I'm going to do it there. I'm also going to do it here, replace my t with a parentheses, plus 4. Anytime I need to do this trick. Now, what we're going to do is I would really like that number when I start, I would like that in parentheses to be a 3, but I got to plug in a 1. So it makes sense that I put t minus 1 here. Because if I plug in 1, 1 minus 1 is 0, and I get 3. That's what I wanted. It also works with 2. If I plug in 2, 2 minus 1 is 1, plus 3. Does it work? Yeah, because 1 plus 3 is 4. So it works there. And then same thing we do here is t minus 1. All we're doing is really taking this minus that. That's what it will be every time. But you can think about, what do I need to do to my plug-in number to get it down to the 0 that I want? Well, I'm just going to minus 1 from it. If I minus 1 there, I get a 4. If I plug in 2, 2 minus 1 is 1, I get a negative 4, plus 4 is 0. So it works. This is how your book's going to approach it. I'm going to clean this up because we're going to have to plug this in. This is equal to t plus 2. This is going to be equal to negative 4t, and then I'm going to get a positive 4, so plus 8, I believe. Let me double check that. Negative 4t, positive 4t, 8. Perfect. Okay. And then we also need dx2, which is going to be 1 dt. And then dy2 is negative 4 dt. Now, all we have to do is we're going to create two different integrals, c1 and c2. And then we're just going to add them together at the end. So I got the integral, the line integral of c1. And then I'm going to go through now and replace everything. I got 3 there. I know x is 2t plus 1. I'm only focused on the 1s. Times y, which is 2t plus 2. Times dx, which is 2 dt. Plus, okay, I got to do x minus y now. 2t plus 1 minus 2t minus 2. That's x minus y. Times dy, which was 2 dt. All right. We would work all that out. I guess we can do that. So we got the integral of c1. And we can change our c's now, right? That doesn't, I'll leave it the way it was there. But now I'm going to change it to t equals 0 to t equals 1. And then I'm going to go ahead and start trying to multiply this out. Okay, I got 6 times 4t squared plus 2 and 6t plus 2. And then I'm going to just do 1 dt for the whole thing. So this thing is gonna, oh, that cancels out, and I get a -1 times 2, so I get a -2. T's cancel, I get a -1 times 2. Now all this is dt. This is gonna work out. Now I'm gonna go one more step and get everything together. I got 24t squared, I got 36t, and then I'm gonna have a 12 minus 2, which is a 10 dt. We can now do that. Okay, 24 divided by 3 is 8t cubed. There we go. 36 divided by 2 is 18t squared. And then we just get a 10t. And thankfully, we're plugging in zeros and ones. The zeros are just going to cancel out, but the ones are going to give me 8 plus 18. I get 36. So that's just C1, though. We got to do the exact same thing now for C2. So C2, I'm going to plug in 3 times x. This is back up to this thing. I'm going to zoom out. Maybe that'll help. Okay, I got 3, and then it's x. In this case is 2t plus 2 times -4t plus 8. That's y. And then dx in this case was just dt. Plus, okay, I got a minus now, x minus y. So I got t minus 4t is a 5t. And then I got 2 minus 8 is a -6. And then times -4 dt. All right, we can go to one integral here. Zoom back in because I don't need that top. So t equals, be careful here, it's 1 to 2. I'm going to start multiplying all this out. I got -4t squared. I got a -8 and a +8, which is going to go away, and then 2 times 8 is 16. Plus, I'm going to go ahead and do this too. I got -20t plus 24, and all that's dt. I'm going to go ahead and combine like terms now. After I guess multiplied, -12t squared plus 48 minus 20t plus 24 dt. Let's go ahead and integrate. I'm going to scoot this up because I'm going to run out of room. All right, so integrate. I go up by 3, divide by my new one. So I got -4t cubed. Take your derivative to make sure it makes sense. Ooh, 48 and 24. 48 and 24 is going to be 72. So 72t. Minus, and then 10t squared. And we're running this from t equals 1 to t equals 2, unfortunately. So we got -4 times 2 to the third plus 72 times 2 minus 10 times 2 squared minus -4 plus 72 minus 10. All right, I'm going to plug this in my calculator. Let me grab that. All right, -4. I'm plugging this all in. To the third, I actually did this a little different in my notes. Same method, but I didn't ever plug this number in, so I got to grab it. All right, that first thing is 72 minus, or plus, whatever's going to end up being. 72 minus 10 minus 58, which gives me, I don't know why I'm plugging this in. My brain is tired. 14. So the whole, let me make this smaller. Sorry, I know that's probably annoying in your notes, but that's all I can do. Of this whole thing, 3xy dx plus x minus y dy, that whole thing is equal to 36 plus 14, which gets me a pretty 50. Okay, well, that looks like it's it.